This is CL125. This has 4 problems here. And so I noticed there's some similarities between the problems. So I'm going to just walk you through these. This is how I would solve this one. I would just, we have to get the x down from the exponent, so I would log both sides, or you could ln both sides if you want. So I'm going to log both sides. Now there's one of your properties of logarithms says that you can take the exponent and bring it down out front to multiply. So I'll rewrite it. X times log of 6. And then I'm trying to get x by itself, so I'm going to divide both sides by log of 6. And then those cancel out, and then I have x equals, I'm going to ask my calculator what log base 10 of 27 divided by log base 10 of 6 is. So I just asked my calculator, log of 27. So log of 27 is about, some little decimal. And I'm going to divide that by log 6. Okay, and I got 1.839. Should we just call it 1.84? We'll just call it about 1.84. It's about 1.84. Okay. Now for the next problem, the first time I did this, actually this is kind of sad. I started doing a whole bunch of brute force on it, I wrote this on somebody's test who got it wrong. I was kind of gonna reinvent the wheel or whatever, but now I see that the better way to do this would be to use a little finesse rather than just brute forcing algebraically through this. So what I'm going to do is, since I noticed there's all these similarities between the problem I just did and this second problem they're asking me to do, I'm going to rewrite this one using some laws of exponents. So I know that I can, the 6 to the x is in the denominator, but if I rewrite it as this, 6 to the negative x, then I know it's not exactly like the problem we just did, but it is very similar to the problem that we just did. And then I'll go ahead, if I do the same procedure that I did over here, by logging both sides and using the rules of exponents, then I think it's going to become clear why they're giving us this problem. So I'm going to log both sides. I'm kind of lazy, so I'm just going to squish log in there. And then that allows me to use the log law that lets this exponent come out front and multiply. So this is going to be rewritten as negative x log 6, and this is still log 27. And then if I would like to get the x by itself, I'm just going to leave that negative sign on there and just divide by log 6 so that you can maybe make a little connection here. This cancels out, and you'll notice that I get negative x is equal to log 27 over log 6. But we know that log 27 over log 6, we just did that problem a second ago, and we found out that it was 1.84. So I'm just going to use the 1.84. You could redo it in your calculator if you want to. But now I have negative x equals 1.84, which is this, well, it's not exactly equal to it. So then I could just divide both sides by negative 1, and I could say, or multiply by negative 1 if I want, that x is approximately equal to negative 1.84. So see how we just kind of finessed our way through the... So the book is trying to show you that it's worthwhile to rewrite these problems, I believe. So the next one is letter C. So letter C says 27, now I feel like I got their number, is equal to 1 over Now, if I use some rules of exponents, I can rewrite this so that it looks a little more familiar. This whole part is in the denominator. If I want to move it to the numerator, I can just change the sign of my exponent. So now that I can rewrite this as and then I can even take it a step further, and I can say, well, anything to the negative exponent, I can take the reciprocals, and so now that's 6 to the x. Well, wasn't that our first problem? So I'm going to just skip the calculations because, let me take it out so you can see both of them. Because they're the same thing, aren't they? 27 equals 6 to the x. This is 27. So this, we already kind of know, because we've already done the problem, that x is equal to about 1.84. And then the last one that they ask you to do is letter D. Okay, so on letter D, it wants me to show, like prove. So they're saying, show me that, well, we've kind of already shown it in the above steps, but this is kind of, I think, what they want. I think they want me to kind of rearrange the left-hand side so that it's equal to the right-hand side. So to rearrange the left-hand side, we've already kind of done this procedure a minute ago. Just if I want to move this into the numerator, I have to change the sign of the exponent, so this will end up being 1/6 to the negative x. And then that's going to equal 6 to the x.